SQA Higher Maths 2017, Paper 2, question number 11. For part A is for 3 marks. Show that sine 2x over 2 cos x, sine 2x over 2 cos x minus sine x cos squared x is equal to sine cubed x. This is for 3 marks, so maybe 5 minutes for this part. Also, you're told that x is greater than 0 and less than pi by 2. So you need to expand the numerator there, so that means that you're starting with the right hand side and you want to prove that that is equal to the left hand side. So this is what you're doing here. So you're starting with that. So starting with the left hand side and you're trying to prove it's equal to the right hand side. Left hand side is equal to, expanding that gives you 2 sine x cos x over 2 cos x minus sine x cos squared x, and that is equal to this cos x cancels out with that cos x in the numerator. Cos x cancels out to leave you just sine x. 2 and the cos x cancels out to just leave you sine x minus sine x. You need to use your identity sine squared x plus cos squared x to write this as 1 minus sine squared x. That identity you're meant to know, sine squared x plus cos squared x is equal to 1, which means that cos squared x is equal to 1 minus sine squared x. That's what you're using here. So that means that what you have there is that's equal to sine x. Multiplying that out gives you, it should be sine x out here, not just sine x. So sine x minus sine x plus sine cubed x, which is equal to sine cubed x, which is equal to the right hand side. So that's it proved for 3 marks. Now part B. For part B, hence differentiate sine 2x over 2 cos x minus sine x cos squared x, and this again is for 3 marks. So you've already shown that this is equal to sine cubed x in part A. So this is what you're going to differentiate. So d by dx of sine cubed x is equal to 3 sine squared x. Bring that numerator, bring the exponent to the front, index to the front, take the index down by 1, and now you need to differentiate what's inside the bracket, which gives you cos x. So this is the differential 3 sine squared x cos x. That's for 3 marks.